Imagine a particle moving across a mathematical space. To do anything meaningful with that movement, we must precisely track its net change in position. Mathematically, we use the Greek letter delta to mean the net change in a value. On a coordinate plane, delta x isolates the horizontal shift, and delta y the vertical shift. Remember, delta is not a separate variable. You are not multiplying delta by x. Delta x is an inseparable concept. It represents one unified measurement, rather than an algebraic operation. To calculate these increments, we use two formal equations. Delta x equals x2 minus x1, and delta y equals y2 minus y1. The order of these terms is rigid. You must always take the stopping coordinate and subtract the starting coordinate. Swapping that order reverses the mathematical direction of the movement, which changes the meaning of any result you calculate from it. Let's test this rule on a grid. We'll map a particle moving from 4, -3 to 2, 5. For delta x, we take the stopping x value, 2, and subtract the starting x value, 4, giving us -2. That negative sign has a direct physical meaning. The particle moved backward along the horizontal axis. Now for delta y. We take the stopping y value, 5, and subtract the starting y value, -3. Consistently following the final minus initial mapping protects the integrity of the math, regardless of the signs involved. Looking at that delta y expression, the calculation requires subtracting a negative number. Subtracting a negative is identical to addition. 5 minus -3 becomes 5 plus 3, resulting to a delta y of 8. The particle moved 8 units up. Calculating increments by the formula will always accurately map the distance and direction traveled. Consider a new scenario. A particle starts at 5, 6 and stops at 5, 1. Pause and calculate both increments. For delta x, 5 minus 5 is 0, proving no horizontal movement. For delta y, 1 minus 6 is -5, tracking the downward drop. These increments operate as directional vectors, accurately capturing movements that are positive, negative, or exactly 0. The ratio of these two increments, delta y divided by delta x, is the slope. This calculation is a starting point for finding tangent lines and derivatives. Mastering strict sign management and formula adherence at this level prevents errors as you move into more advanced calculus.